Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look to see how we actually detect different gases. So hopefully by the end of this lesson you're going to be able to describe how we carry out these different gas tests. To start off though, we've got 3 questions based around our previous lesson, so have a go at answering those in your books. Question 1, hopefully we said that spectator ions are in the reaction mixture but do not take part in the reaction themselves. So 1 mark if you got words to those lines. Question 2, 2 marks available, 1 for each of our half equations here. So 1 mark if you wrote down Mg makes Mg2 plus 2e minus, and a 2nd mark if you said Cl2 plus 2e minus makes 2Cl minus. You've got to have the balancing right to actually get the mark for each of those. So if we have a look at how we answer question 3 then, what we've got is we've got to write the net ionic equation for the reaction. HCl plus KOH makes KCl and H2O. So first thing to do is start by writing out all of the different ions we have involved. So if we start off, we've got H plus and Cl minus, that comes from this one. Then we've got K plus and OH minus, because remember hydroxide is a compound ion. And then across the other side we have K plus and Cl minus, and then here we've got water, so that stays as water. So that's our complete ionic equation. Then what we need to do is identify our spectator ions. So these are the ones that remain unchanged on the two sides. So if we look, we've got a K plus here, and we've got K plus here, we've got Cl minus here, and we've got Cl minus here. So those are our spectator ions. All we then need to do is we ignore those as we write it out. So we've got H plus, and we'll include the state symbols, so AQ, and we've got our OH minus, again in the aqueous state, and that's going to make H2O, which is a liquid. And that's it. That is our net ionic equation for the reaction. Okay, so the first gas we need to know how to identify is carbon dioxide. Now, I'm hoping this is one that you have already encountered at some stage in your science careers at school. So see if you can describe how we test for carbon dioxide. When it comes to testing for carbon dioxide, what we need to write down is Limewater goes from colourless to cloudy. So there's basically three keywords to remember there: Limewater, colourless and cloudy. Please do not write down it starts off as clear, because clear isn't accurate. We can have a solution that's red but it's clear because there's no bits floating in it. Colourless is the correct term here. So Limewater goes from colourless to cloudy, and we can see that in the picture at the bottom. So we've got our Limewater initially, as it starts to change and goes that slight cloudy colour, and then how you're probably used to seeing it at the end of the experiment. So make sure you've got that written down if you've not already got it. What is Limewater then? It's not water with lime in it, okay? It's nothing related to lime the fruit at all. Limewater is actually calcium hydroxide solution. Now, what we actually see happening when we start off with our lime water, the calcium hydroxide solution, and we bubble carbon dioxide through it, then the carbon dioxide is going to react with the calcium hydroxide to make two products. It will make water and calcium carbonate. Now, calcium carbonate is a white precipitate, and hopefully we remember that a precipitate is an insoluble solid. So what we end up with are little bits of white solid floating around within the water we've made, and that is what gives it that cloudy appearance. So jot down those 3 sentences for me in your books. Let's see if you can write me a word equation for the reaction of our carbon dioxide with the lime water. So see if you can write the word equation for that. Hopefully what we've got written down is carbon dioxide plus calcium hydroxide, which is our scientific name for lime water, makes calcium carbonate plus water. Give yourself a tick if you got it right. The next test we've got is the test for chlorine. Now, I doubt you've experienced this one in school yet. So when we're actually testing for chlorine, what we use is a bit of blue litmus paper. Now, the first thing we need to do is we need to make that damp with a drop of tap water. So we start off by dampening the blue litmus paper with a drop of water. and then we hold it near the container that contains the substance we want to test. When you look at it, what you're going to see is initially it will turn red and then it goes white if chlorine is present. Now, the reason for that is that as the chlorine comes into contact with the water, it dissolves and forms an acidic substance, hence it goes red. But chlorine also acts as a bleach. So when you leave it in there for any length of time, then it changes that red coloration to the bleached white colour. So that's why it goes red first of all, because it's detecting the acidic substance as the chlorine dissolves with the water, and then it goes white as it's bleached. If you don't dampen the blue litmus paper first, it doesn't work, because obviously you can't dissolve the chlorine in non-damp litmus paper. So the water is essential for actually allowing the chlorine to dissolve to make that acidic substance we can test for. So jot those points down on how we test for chlorine. The third gas we need to know how to test for is hydrogen. So see if you can explain how we test for hydrogen. Again, this is one I'm hoping you've done lower down the school. To test for hydrogen, what we need to do is hold a lit splint into the tube of our actual choosing, and if it makes a squeaky pop sound, we've got hydrogen present. So lit splint makes a squeaky pop is our hydrogen test. The fourth and final gas we need to test for is oxygen. And again, I'm hoping you encountered this lower down the school. So have a go at describing how we test for oxygen. To test for oxygen, what we need to do is hold a glowing splint into our container, and if oxygen is present, that glowing splint will relight. So a glowing splint relights is the test for oxygen, and that gives us our 4 different tests we need to know. And it's worth taking the time to actually learn these at this stage, because they're going to keep cropping up throughout all of the different chemistry topics, and they could occur as questions on either your paper 1 or paper 2 for chemistry. There are some instances where you may already kind of have a good idea about what gas is present before we do any test, because we all have a sense of smell. Now, the key thing here is when we're actually using our sense of smell in chemistry, that we're not going to be doing something that's going to then lead to our demise. That would be bad. So what we have is a technique we use for safe smelling of chemicals. So in order to do this, we don't get the container containing our chemical, shove it right under our nose and take a nice big whiff and inhale as much as possible. Because if that's something like chlorine, then you've just inhaled a couple of lungfuls of chlorine gas. Now, if we know anything about our history lessons, we know that inhaling chlorine gas is a pretty bad thing to do and could lead to your death. So not a way we would recommend it. The way you smell things safely is you hold the container a few centimetres away from your nose and then you waft the smell towards you. I always describe it as kind of doing that royal wave the Queen does, that kind of rotating your wrist to gently waft the smell towards you. And then you're still not taking a massive lungful here, you take a cautious, gentle sniff. The whole idea here is just to get a little hint of the chemical just to those receptors in our nose so we can detect the smell, but not actually inhale vast quantities of the stuff. Final thing for today then are the 3 plenary questions. So have a go at answering these in your books. I would also recommend that you create yourself some flashcards about the different gas tests. So on one side you can just have the question, how do you test for, and whichever gas it is, and then on the reverse have the procedure and the expected outcome for each one. And add that to your flashcard collection, because the more of this that you do throughout your course, the better prepared you are going to be when it gets to year 11. Leaving the creation of all these flashcards until year 11 is pretty silly, because the more you learn as we go through, the better prepared you're going to be and the easier some of the later topics will be. Because if you're taking in this foundation information now, then when we then build on it, you've already got that knowledge there and you're not having to learn the whole thing from scratch each time. So 3 questions, have a go answering those in your book. I'm going to leave those up for about 4 minutes today.